Welcome to Jacked Engineering. Today we'll be going over LeetCode problem number 88, merge sorted array. This is the first in the interview 150 to prepare you for interviews. So we will be doing this in C++, and let's go over what the problem says. You are given two integer arrays, nums 1 and 2, sorted in non-decreasing order, and two integers m and n representing the number of elements in nums 1 and 2. Merge nums 1 and 2 into a single array sorted in non-decreasing order. And I'll save some time instead of reading all of this. You take two arrays, numbers 1 has placeholders, the vector nums 1 has placeholder values to account for the number of elements in nums 2 so that you can actually merge them together. Now, I was playing around with how to solve this earlier, and there's actually two ways to do it, and they're both are equal in speed, but one uses more memory. So the first that we won't be going over is typically how you would do merge inside of a merge sort algorithm. That be where you create in C++, you do a new vector, and then you'd use a two-pointer method, and you'd loop you'd loop through each different vector, checking the indices, comparing, and then creating a final array in sorted order, and you would return that. That's not really what this wants us to do. It wants us to do everything within inside of nums 1. So how do we do that? So let's say that we have two arrays. This is going to be nums 1, right? And this is going to be nums 2. Okay? So we'll have, we'll have 1, 3, 2, and 4. So instead of having pointers at the start and comparing that, we're going to have pointers at the end. So these are 0 placeholder values. So we'll have three different pointers. We're going to have an insertion pointer. So we'll put that in red. We'll have an insertion pointer, which is going to go here. And then we're going to have our pointers that point to the end of nums 1 and nums 2, or the values that we're comparing at least. So now we can proceed as a normal merge sort algorithm would work. So we can compare nums, this is nums 2. We can compare a pointer at nums 2, and we can say, okay, is it greater than what we're looking at in nums 1? Well, the answer to that is yes. So we can then take this value and insert it into our insertion pointer. So we now have an array that looks like this: 1, 3, 0, 4. Okay. Because we inserted from nums 2, we can now decrement that pointer and have it point to 2. 3 is greater than 2. And so because of that, where our new insertion pointer is, right, we will be putting 3, because 3 is greater than 2, into where our insertion pointer is. So this now gives us an array that looks like 1, 3, 3, 4, with our insertion pointer right here. Now, in order to append the rest of nums 2, all we're going to do is create a condition that says if nums 2 still has numbers, then insert them and decrement our insertion pointer. I think you can get the idea. So because 2 is the only remaining number, we insert 2, and our final result will end up with 1, 1, 2, 3, 4. So let's go ahead and implement that. So the first thing that we talked about were two pointers. So we need int I is going to be equal to m minus 1, right? Because if the size is 4, then we need that pointing to index 3. That will be the end index of nums1 if the size is 4. We'll have int j is equal to n minus 1. And then we're also going to have our insertion pointer. So what is the insertion pointer going to be? Well, because n is the number of elements in nums2 and m is the number of elements in nums1, let's say we have 2 elements in each. Well, if we have 2 elements in each, that will make the total length of nums4 equal to, of nums1 equal to 4. So you can either do it like this. You can do nums1.size minus 1, or we can just do m plus n minus 1. Great. So now all we need to do is have our while loop condition. While I is greater than or equal to 0 and j is greater than or equal to 0, we want to check if nums at I is greater than nums at j at our insertion point. At our insertion point, we want that to equal the greater number. So then we can do the same logic for the opposite scenario, right? So this else statement is if the nums2 index position is greater, or the number corresponding to that index position is greater. And then the base if is if the number at the index position in I nums1 is greater, right? But we have to actually decrement in order to, right, from our drawing, we need these blue arrows to go down, right? This blue arrow needs to keep decreasing as we go through. So there's 2 ways to do that. We can either do k minus minus and I minus minus, or the new way that I recently learned about with C++ is you can just do this, right? So those are going to be equal to the same thing as if outside of the loop you just wrote the corresponding same statement, okay? So now that we have that, we need one more while loop, and this while loop is what says if there are still elements in j. So if while j is greater than or equal to 0, so this is in a condition that we've looped through all of nums1, well then we are going to insert in nums1 at our insertion point. We are going to insert nums2 at j. Great. And then same thing, we're just going to have to decrement k and j. And then if that doesn't, or if you don't like that format, we can just do it like this. Great. And this should have correctly modified nums1, sorry. This should, I did the same thing right here. Come on. Oh my gosh. Okay. And there we go. So now we can see that the base test case is passed. We'll go ahead and submit this, and we'll see if this passes all the test cases. There we go. We can see that this is the most efficient way to do this. But just in case you're curious, you can see that if you click on this blue graph, you can see that this person did the first thing that I was talking about, where you can create a new vector or array and then essentially increment through the 2 different vectors, and then do the same 2-pointer method, except instead of going from back to front, you're doing front to back. That's all. Thank you for watching. Stay tuned. We'll be going through all 150 problems inside of that top 150 list. Thanks for watching.